Hi everyone, so now we're going to learn to deal with vectors in a more mathematical way. And the thing is that there's no one way to do this, there's several ways to do this, and it depends on the problem, you choose one or the other. So let's start with this simple vector. So I got this vector that goes from here to here, so this vector. And I would like to tell somebody else to draw how to draw this vector without ever showing them the vector. Now, every single vector, when we draw it starting from 0, 0. It really doesn't matter what they are. I could take this vector and put it over here, or over here, or over here. It would always be the same vector, but it's so much easier to analyze it if I started from 0, 0. Because then I just need to take a look at this point in order to know everything that I need to know about the vector. Otherwise, if the vector is, for example, from here to here, I would have to be subtracting all the time, and that's a pain. So we always represent vectors are starting from 0, even though they can really start from anywhere, and if they have the same magnitude and direction, they are always the same vector. So now there's two ways I could communicate this thing. One way is possibly the most obvious, would be say, well, if you move 4 to the right and then 2 up, then here's your vector. So basically the tip of the arrow is 4 to the right and then 2 up. Or in a more mathematical language, it's at point 4, 2. And we could write this up like this, right? 4, 2. These are basically two coordinates of a point. But in this case, they don't represent a point, they represent a vector, which is a different thing. Because a vector is the difference between 2 points. It goes from here to here. It has a length, whereas a point does not have a length. So this is a vector. This is a vector 4, 2. And this just tells us that its x component is 4 and its y component is 2. I could also give you a different vector. For example, I could give you this vector, and then before I do anything, just think about what the components would be. Hopefully you thought enough. And in this case, it would be just -3, -2. So a piece of cake. -3, -2. Done. Okay. And so on and so on and so on. We call this thing the x component of a vector. And make a guess for this one. Exactly, it's the y component. So that's one way you can do things, but there is a very different way to do things. So the other way to do things is saying, well, here's where your vector is. You take an angle of, in this case, 36.9 degrees from the horizontal, and this is the horizontal. In fact, this is the horizontal. And then once you're there, you draw a line of length 5. And this would also enable me to draw any vector, right? You could say, hey, I want an angle of 180. Okay, 180. And then I want a length of 3. Okay, a length of 3. And so on. But remember, we don't call this a length, we call this a magnitude. So basically, if I know the magnitude of the vector, and I also know the angle that it subtends, and the word here, you will see it very often. To subtend an angle is just to do an angle. So the angle that there is between here and here says that this subtends an angle of 36.9. So if I know the magnitude and the angle that it subtends with the horizontal, then I can also draw the vector. So a lot of the times what we're interested in is in changing from one representation to the other. Sometimes we want to know components because it's much easier to do components when you are, for example, adding up different vectors. Sometimes we are interested in magnitude and direction because we just want to know how much force there is, and we don't care in which direction really. So really the idea is to be able to find the components. For example, if I have the magnitude and direction, and then alternatively, if I find the components, I should be able to find the magnitude and direction. Now, I don't want to do this for you. I want you to figure this out. If you can't, I will later on show you how to do this. But first I want you to think very, very hard about this before you move on with anything else. So I'm going to give you a problem. I want you to try. If you manage to figure this out, fine, move on. If you think that you're completely lost and you can't do this, then ask for help. If you're doing this at home, then stop, and then I'll show you how to do this during class. So here's the problem. I have a vector, for example, that has this aspect. So its components are, of course, 2 and 3. I would like you to find, first thing, its magnitude, which is really just its length. And the second thing, I want you to find this angle here, the angle that it subtends with the horizontal that we normally call theta. That is the first problem that you have. Now here's the second problem that you have. In this case, I'm telling you that I have one vector, and I'm giving you the magnitude and the direction. And I'm telling you that the magnitude is 10, and that the angle with the horizontal is 30 degrees. And now what I would like you to do is to tell me the components. Now, when you try this, it would be good to have a little clue. My clue is that you're going to need trigonometry to solve this. Use what you know about trigonometry, in particular cosines and sines, and then you're going to be able to find the two components of this vector, the x and y components. Similarly here, you're not going to need trigonometry for the magnitude, but you are going to need trigonometry to find the angle that is subtended by this vector. Good luck, try it out, check your results, and then if you're right, move on. If you're not, stop, and then I'll show you how to do this. See you later.